You've probably already decided what death looks like. The heart stops, the brain shuts off. One moment you're here, and then you're not. A clean ending, a light turning off. That's the version most of us carry around without ever questioning it, and it's almost entirely wrong. Because what neuroscience has documented inside the human brain during the minutes after death is not a shutdown, it's the opposite. And the implications of what researchers have found are strange enough that some scientists spent years debating whether to publish the data at all. Let's start with what we thought we knew. For most of medical history, death was simple to define. The heart stops, breathing stops, the brain goes dark. The flat line on the monitor was the period at the end of the sentence. There was no ambiguity, no gray area, no in-between. You were either alive or you weren't. But then medicine got better at bringing people back. As CPR and defibrillation became standard practice in hospitals during the 1960s and 70s, doctors started encountering something they had no real framework for. Patients who had been clinically dead, no heartbeat, no breathing, no measurable brain activity, were coming back. And a significant number of them were reporting the same thing. They had experienced something while they were dead. For years, these reports were dismissed. Hallucinations, oxygen deprivation, wishful thinking, a brain dying in an undignified, stuttering way and producing electrical noise that a confused mind later mistook for real experience. That was the official position, and most of the medical establishment accepted it without much investigation, because investigating it meant taking it seriously, and taking it seriously felt unscientific. Then one cardiologist decided to actually study it. Pim van Lommel worked at the Rhine State Hospital in the Netherlands. He had been resuscitating cardiac arrest patients for years and had heard enough near-death accounts from his own patients that he could no longer dismiss them as irrelevant noise. In 1988, he started a systematic study. Between 1988 and 1992, he followed 344 patients who had been successfully resuscitated after cardiac arrest. He interviewed them all within days of being brought back, and then again 2 years later, and then again 8 years after that. 18% of them reported a near-death experience. They described moving through darkness toward light. They described encounters with deceased relatives they hadn't seen in decades. They described watching their own resuscitation from somewhere above the room, looking down at their own chest being compressed by doctors whose faces they could describe in detail. And they described all of it with a precision that bothered Van Lommel more than anything else. One patient had been brought in unconscious. While the crash team worked on him, a nurse removed his dentures and placed them in a specific drawer of the crash cart. The patient had no way of knowing this. He was dead by every measurable standard when it happened. When he came back, he described the exact drawer. He described the nurse's face. He described what she was wearing and what she said to the doctor working next to her. Van Lommel published his findings in The Lancet in 2001. It was one of the most methodologically rigorous near-death studies ever conducted. The medical establishment was uncomfortable. The paper made no supernatural claims. It simply documented that something was happening inside dying brains that current science could not fully account for. And it recommended firmly that science take that seriously. Most of science continued not to, but the neuroscientists kept working. A decade later, in 2008, a British cardiologist named Sam Parnia launched what he called the AWARE study, a large-scale attempt to test whether patients who reported leaving their bodies during resuscitation were actually seeing anything real. He placed hidden images on shelves near the ceilings of cardiac wards in multiple hospitals, images that could only be seen from above. The logic was straightforward. If patients were genuinely floating above the room and watching their own resuscitation, some of them should be able to describe what was on those shelves. Of 2,060 cardiac arrest patients in the study, 330 survived. Of those, 140 agreed to be interviewed. 9 reported near-death experiences that met strict criteria, and 1 patient described his resuscitation in verifiable detail: the equipment used, the specific actions of the staff, even sounds he heard, during a period when he had no measurable brain activity. Pania stopped short of strong conclusions, but he made one comment that stayed with the field. The evidence suggested something was happening in the dying brain that science did not yet understand. In 2013, a team at the University of Michigan, led by Dr. Jimmo Borgigan, took the question into the laboratory. They had been measuring the brain activity of 9 rats in the precise moments after cardiac arrest. They wanted to document the decline, the slow fade. What they expected was a gradual drop in electrical activity as oxygen ran out and neurons failed one by one. What they found was a surge. In the 30 seconds immediately following cardiac arrest, all 9 rats experienced a dramatic spike in brain activity. Gamma waves, the neural frequency associated with the highest levels of conscious processing, perceptual binding, and focused awareness, spiked to levels that exceeded anything recorded during normal waking life. The brains were not shutting down. They were, by every measurable standard, more active than they had been at any point while the animals were alive. It's worth understanding what gamma waves actually represent. In a living conscious brain, gamma oscillations are what allow different regions to synchronize with each other. They are what turn raw sensory input into a unified experience. The sound of a voice and the sight of a face become one person because gamma waves coordinate the regions processing each of them. Neuroscientists consider gamma activity the closest thing we have to a neural signature of consciousness itself, and it was this specific frequency that spiked in every single one of those 9 dying brains. Borgigan described it as a highly aroused brain state, not a dying flicker, not random noise, a coordinated, structured storm of electrical activity in a brain that had just been cut off from all blood and oxygen. The question the study raised was one that nobody had quite asked so directly before. If this surge happened in every single rat that was measured, was it happening in humans too? In 2023, a team at the University of Michigan got the answer. The researchers, led by Dr. Ahmal Zemar, had been monitoring 4 comatose patients, all adults who had suffered severe, irreversible brain injuries. Their families had consented to the withdrawal of life support, and the team received permission to record continuous high-density EEG measurements throughout the dying process. 2 of the 4 patients showed no significant changes. Their brains faded as expected. But in the other 2, something happened the moment the ventilator was removed. Their brains surged. Gamma wave activity spiked dramatically. Specifically in the parietal and temporal lobes. These are not random areas of the brain. The parietal lobe is involved in spatial awareness, self-perception, and the integration of sensory experience. The temporal lobe handles memory, language, and the processing of emotionally significant events. The region where the 2 lobes meet, the temporoparietal junction, is the area most consistently activated in studies of out-of-body experiences. It is the region that, when stimulated with electrodes in awake patients, reliably produces the feeling of floating above one's own body and looking down at it from the ceiling. This was the region that lit up at the moment of death. The surge in both patients lasted approximately 2 minutes before the signal faded entirely. The researchers were explicit about what they could and could not conclude. They could not determine whether these patients were conscious. They could not determine what, if anything, was being experienced inside those 2 skulls. But they were equally explicit about what the data showed. These were not the brains of 2 people going quietly dark. At the precise moment of death, these 2 brains became more active than they had been at any point during the preceding days of coma. Zemar told reporters afterward that the biological capacity for a surge in conscious awareness appeared to be present at the moment of death. He was careful, he was cautious, but he said it. Here's what all of this actually means. Your brain does not stop when your heart stops. Not even close. After cardiac arrest, blood circulation to the brain continues for several seconds from blood already in the vessels. Brain cells deprived of oxygen begin to fail, but cellular death is not instantaneous. Neurons can maintain electrical activity for minutes after circulation stops. In cases of cardiac arrest without any resuscitation attempt, researchers have recorded meaningful brain activity for anywhere from 2 to 10 minutes after the heart has stopped beating. During those minutes, something is happening inside your skull that nobody on the outside can observe. Whether that something constitutes experience, whether there is anything it is like to be a dying brain, is a question that science cannot currently answer. But the machinery is still running. The signals are still firing. Whatever the brain does at the end, it does not do it quietly. Some neuroscientists have proposed that the surge is connected to the release of endogenous DMT, a powerful psychoactive compound that the brain appears to produce naturally during extreme stress. Researchers at the University of Michigan found evidence of DMT production in dying rat brains in 2019, specifically in the visual cortex, at levels that would be considered psychoactive in humans. If the same thing is happening in human brains, it would provide a partial neurochemical explanation for why near-death experiences so consistently feature vivid visual phenomena. The light, the tunnel, the overwhelming sense of reality that survivors describe as more real than ordinary life. It would not explain why those experiences are organized and coherent, but it would explain why they are so intense. And here is the part that almost nobody talks about openly. The studies of near-death experiences across different cultures reveal a pattern that is difficult to explain by hallucination alone. A child in rural India, a retired soldier in Ohio, an elderly woman in rural South Africa, and a teenage boy in Tokyo all independently describe the same experience, the same darkness, the same movement toward light, the same sense of encountering people they knew who had already died, the same feeling described by nearly every survivor that the experience was more real than any ordinary moment of their waking lives, not dreamlike, not hazy, hyper-real. If these were simply the result of a dying brain generating random noise, you would expect the experiences to vary wildly across individuals and cultures, the way dreams do. But they don't vary, they converge. This is the finding the field has struggled most to absorb, because it forces a question nobody wants to ask directly. If conscious experience is a product of brain activity, and brain activity continues after death, then where exactly is the line between alive and gone? We define death legally and medically because we have to. We need a moment, a time of death on a certificate, a before and an after. But the biology does not cooperate with that need. The biology insists that dying is not a moment, it is a process. And inside that process, the most complex structure in the known universe appears to produce its greatest electrical intensity right at the end. Some scientists argue the surge is meaningless. As neurons lose their voltage gradients and electrochemical balance collapses, electrical discharge becomes unstable and chaotic. A dying battery doesn't go out smoothly. It flickers and spikes before it goes dark. What looks like organized activity might be nothing more than incoherent noise, signal without content, sound without meaning. But other researchers point out that the activity isn't structurally random. It follows the same gamma wave patterns associated with organized conscious processing. Random neural noise looks different on an EEG. It lacks temporal coherence. It lacks spatial organization. What is being recorded in these dying brains has both. The patterns have timing. They have structure. They look less like a system collapsing and more like a system executing one final coordinated program. We do not know which interpretation is correct. That is the honest answer. What we do know is this: everything you have ever thought, every memory you have stored, every version of yourself you have ever been, is encoded somewhere in the electrochemical activity of approximately 86 billion neurons. For several minutes after your heart stops, those neurons are still firing. The ancient Greeks imagined the soul escaping the body at death like a last breath, an instantaneous release. Medieval theologians pictured a clean, precise moment of departure. Even modern secular culture has inherited this same basic shape, the flat line, the moment, the switch. But the data tells a different story. The end is not a switch, it is a slow dimming. And inside that dimming, the brain produces more activity than it did at any moment before. What happens to you in those minutes, whether your brain replays your entire life in compressed and luminous detail, whether it generates something like the tunnel of light reported by millions of near-death survivors across every culture and continent on Earth, whether it simply fires its last signals into the dark with no experience attached to them at all, no one who has stayed dead has ever been able to tell us. Every person who has ever lived has gone through this process, every single one, and every person who has ever died took that information with them into a silence that no instrument has ever been able to read. The brain's final act is a surge, not a silence, and until someone finds a way to interpret what that surge contains, we are left with a question so large that most of us spend our entire lives not looking directly at it. What was the last thing your brain ever experienced?